Hey everyone, welcome back to my YouTube channel SummarizedAI. As we know, in the real world, everything around us is an object, whether it's a bottle, car, bike, or even an animal. Each of these objects has its own characteristics, which is nothing but properties, and can perform certain actions, which is nothing but behavior. Let's take a car as an example to understand this better. A car has several properties such as brand, color, and speed. Brand can be Tesla, BMW, or Toyota. Color can be red, blue, or black. The speed can be zero when it's stopped, increase when accelerated. And it also performs actions too, like stop, accelerate, and start. Now, think of how cars are built. Before any real car is made, engineer first designs a blueprint, something like this. This blueprint defines how the car will look, what features it will have, and how it will behave. But it's not a real car yet. In programming, also, a class works in the same way as that blueprint of any object. A class defines properties and an action. What properties an object will have, like brand, color, or speed, and what actions it can perform is start, stop, accelerate, control speed. Properties, what we are seeing here is nothing but we call as attributes in Python. Similar to that, actions in Python we call as methods. Once the class is created, we can use it to build multiple real world objects, which we call as instance and represents a real car, just like manufacturing multiple cars from the same design. So the flow looks like this. It's a real world car, create a blueprint, convert blueprint to a class, use the class to create real car objects in the code. Each object created from that class represents a real instance for your own car with its own color, speed, and brand. And also, it will have its own behavior. Now, if we try to understand in detail, okay, now this particular blueprint or the car, it has a brand, a color, and speed. And also, a car can start, stop, and accelerate. The word like has represents the feature of that car or the characteristics, or we can call it as attributes in Python. Okay. Now, what car can do is nothing but the actions it can perform. And the actions we call in Python as methods. Okay. I hope it is clear. So a class contains properties and actions, which is nothing but method and attributes. Now, if we go next, OOPS, object-oriented programming. Okay, it has four major pillars, or we can say four core concepts as abstraction, inheritance, polymorphism, and encapsulation. All these four things we are going to discuss in the same video because these are really, really important to understand, and every section will take a good amount of time. So, without wasting time, let's go ahead and get started. Okay. Now, as discussed, let's first create a car.py. Okay. Now, let's first create a class car. Okay. Now, after creating a class car, let's create a function underscore underscore init underscore underscore. And here I can say self and then brand color speed. Don't worry, I will explain you each and everything. What is self? What is init? What are these parameters? I will explain each and everything. Self dot brand equal to brand. Now self dot color equals to color. Now self dot underscore underscore speed. This will also I will be explaining you. Don't worry. Okay. Now once we have this, let's print the values. So here we are saying format and car created. Okay. And here we can say self dot brand. Okay. Now comma self dot color comma self dot speed. Okay. Now we have this thing here. Now let me go ahead and create an object of this class. Okay. Now the brand is BMW. If you see here, this particular class, we are going to pass three parameters and I will tell you how these parameter works. Okay. So BMW, white, and then we have speed. We can say 100. Okay. Now let me go ahead and run this code and then we will start our discussion. Now you say the car got created. We have a class, we have attributes. Okay. And as soon as we created an object of this particular class, the class object got created. Correct. As soon as we call this class with these parameters. Now let's try to understand. Okay. This particular underscore underscore init underscore underscore is a special method get called automatically when we create a new car object every time. What do I mean every time? If suppose I create a one more object of car as car underscore one or car one, anything is fine. And here I say in place of BMW Honda and the color red and the speed is 90. Okay. Now if I rerun, you will see now we have this BMW also and Honda also, which means as soon as I create an object of a class, this particular line is getting called. So this function is nothing but a constructor of a class. So whenever you are going to create an object, this will get called by default. Okay. Now, point to be noted here, self is nothing but it represents to the current object. What do I mean by current object is for this particular line, the current object is car. Okay. So if I'm making that change in the value of brand color or speed for current instance, it will affect only this particular car object. Okay. Now here, this is a current object and we are saying dot brand. With the help of self, we are creating a class label attributes, characteristics, which we say. Okay. And these characteristics, because it is class label, I will be able to access it from outside of class 2. Okay. So I'm saying car.brand, car.color. Okay. Let me run now. See, I'm able to access. But you would have noted I have given underscore underscore speed. Okay, let's try this also, and then I will explain you what is happening here. So if I say car dot underscore underscore speed, now you see it printed the BMW in white, but as soon as the turn comes for speed, it says it has no attribute, something like this. Why? Because underscore underscore represents to the private in Python. So it's a private variable of this particular class. You cannot use this particular variable outside of class scope. What do I mean by that is, if I have a class car here, and if I say indentation here, if I indent, then inside this particular class, I can use this particular variable anywhere. Okay. So let's see, if I wish to access this variable outside of this function, then what I can do here is I can create a function and say get speed. Okay. And it will take this particular self parameter. And then if I say speed colon, and let's format also. And then if I say self dot speed, okay. Now you see here, let me remove this line. It is breaking. And in place of this line, I will be calling star dot speed get speed method. Okay. So this is nothing but a method. Okay. Now let me save it and clear the console and rerun this code. Now you'll see we have a speed 100. Okay. Good. Now I'm able to access the speed alone outside of class using the method because it's a private variable to a class. Now, one more thing your point to be noted. If I print the car dot brand, here it is BMW, color is white, okay? But as soon as I say car dot color equals to black, okay? Now, if I call this line again here, okay, if I call this line here again, you will see the color was white and the updated color is black, okay? Which means I am able to update the attribute value from outside of class because it is a public attribute. Okay. Now, if I do the same thing for speed, okay. So let me do this for speed. For speed, I'm saying 50 and a color underscore speed. Okay. Let's see. It did not give any error. Okay. But if you see, we have defined a speed of 100 here. Then we tried to update the speed assignment. It ignored that assignment because this particular variable is a private. Okay, if you try to make any change, nothing will happen. It will still be 100. Okay, if it is public, you can change the values. Okay, but now here, if I print the same things, okay, if I print, for example, car one dot color, okay, and car one dot brand, and then if I call this particular method here, okay, let's see. And let me give a separator here. Great. Oops, what is the issue here? Line number one, something went wrong. No, I don't see any issues anywhere. And it is saying, oh, invalid syntax, Python.5. We have some invalid syntax here. At the line number one, it is not showing to me. Okay, give me a minute. Let me control Z this. Okay, and let me paste it again. Now, if I try to run, which means something is wrong here, print color one dot color car one dot brand car one dot get speed. I don't think so any error is there, but why it is saying oops merit syntax. I think while saving I made some mistake. Okay, let me control Z. Oh, I think I got the mistake. Let me report my changes, but that's fine. Let me report my changes quickly. I got the issue. The issue is here. I have to come out of it, quit. Okay, clear the screen. Now, if I try to run this code again, So you would see we have a speed of 90 here. Now we had a speed of car to 100. We changed the speed of car to 50. It got changed. But you see there is no impact on car 1. Okay, now if you think like I have initialized car 1 here, now I can go and make the change here again and rerun. It's the same output. It's a 90. Okay. And in between we have updated the speed of car, not car 1. So, which means whatever changes we are doing on this particular object, it will be impacting that object only. Here, nothing will get impact to other objects. Okay. Now, there is quickly a thing to understand. Okay. What we discussed. So, init method, what we are having it here is an optional. If you don't create this particular method, it will by default get created by Python. Okay. And self.brand and self.color are instance variables initialized during object creation. This is what we discussed. Now, there are some key points of this particular constructor. Okay. What the key points? There are three key points. The very first key point is constructor will always name as underscore init, underscore init, underscore. Okay. Now, the second is constructor gets called automatically during object creation. That, that is what we saw. Now, the third point, important point is constructor don't return anything. So if you return anything from here, you you can return, there is no harm, but you will not be able to use this particular return anywhere. Okay. So if I say test and if I try to run this, it will give the error because you cannot have return type. See, that's where if you keep it also where you are going to use, you cannot use it anywhere. So that's where it is not allowed. You cannot have a return type for any constructor. And this rule is there for every programming language like Java, C Sharp. They also don't allow to have a return type as part of the constructor. Okay. Now this is something we have for constructor, and this you can say as a difference in between constructor and the method. Okay. Now quickly one more point I wish to add here. Now suppose you have one more constructor here. Okay. Or I would say before that, let me remove the speed from here. Okay. Let's remove the speed from here and from here to now only two parameters I'm passing. Okay. And before this two parameter, okay, before this two parameter, if I will create car underscore two second object, okay. And in this second object, if I say car and something like this, okay, you see, oh, let me first car to 19. Okay. So you see, we have said car two. Okay. Now this is giving us an error. Why? Because we have overridden the constructors, but we did not overridden the default constructor, which is this one. Let me tell you, which is this one, car created. So car created with nothing. Okay. So this is the one. Now, if I try to run this, it should be working. Okay. It is saying car.init missing three required positional arguments: brand, color, and speed at line number 22. But why it is saying this? I have already created a constructor which can have two parameters. Okay, so let's try with two parameters only. Let's say Honda and say red. Okay, now if I try to execute, see, now also it is saying car.init missing one required positional argument speed. Okay, now let me do one thing. Let me move all this after this one. Okay, and let's see like what happens. Okay, now if I move out this after this one, it is saying car.init takes three positional argument but four given. Okay, now it is giving an error. Why? Because it is giving the precedence to that constructor which is written in last. Okay, now let's move this one to last. Okay, because it is saying four parameters, four arguments. Why? Because current object, brand, color, speed, four argument. But what it was expecting earlier? Only three, which is self, brand, and color. But I have moved this one to last, the default parameter. Now it will be saying take one positional argument but given four. See, takes one positional argument but three were given. Okay, which means whichever constructor you are writing in last, that particular constructor will take the precedence. Okay, it's a different from the other programming language how we write in Java. Okay, or C sharp. Now up till here we are good. Okay, and we have to understand one more thing here. Here the speed, like the speed what you saw here, underscore underscore speed, correct? Property in car class is hidden. We saw that this is a hidden property, which is a class level property. You can only access or add speed using get or set speed method. Okay, so for example, if I say def, okay, define a function set speed, okay, and then here if I say self comma new speed, okay, say this. Then if I say here self dot underscore underscore speed equal to new speed. Okay. Now if I say here um, car dot set speed 20, and if I again print this, okay, so you would see our speed got updated. Okay. So we tried to update here, it did not work because it's a private attribute to that class. But if you do it through function, it will go inside this function with the 20. Okay. And then now we are in a function, and function is inside this particular class, which is a car class. And here we have a access of self. And as soon as we say self dot underscore underscore speed, this particular value will get assigned to this one. Okay. Now, whenever you are going to say get speed, it will give you the updated value. Okay. Now, this particular underscore underscore speed keeps your speed safe and organized. And this is nothing but shows encapsulation, because you capsule this particular attribute in a class. No one can access outside of class. Okay. Encapsulation is all about wrapping variables and methods that operate on the data into a single unit. Okay. So this was all about encapsulation. Okay. Now let's move. Let's move and let's remove all these things we don't require. Now let's create a class, one more class, and give this class name as Tesla. Okay. And inherit this class, car class here. Okay. Now you would be saying, what is inherit or inheritance? Okay. So as you may be knowing, inheritance allow us to access attributes and methods from parent class. So here I set Tesla and car. Okay. And if I say pass here, and if I go down and say Tesla equal to Tesla. Now, if I pass here the same thing, um, CMW, for example, and then say violet color, and then say 45 is the speed. Now, as soon as I say this, let's see what happens. Okay, you see, car created with CMW violet 45. Why? Because as soon as you write car here, it is Tesla is inheriting the car, which means all the functions, whatever we have written here, apart from this private, is available into this class also. Okay. And if I say here, Tesla dot get speed. Okay, then you see what will be the output. I'm able to access the speed. Now, if I say Tesla dot set speed, and if I give the speed as 125, then see our speed got updated to 125. Okay, we we saw that underscore underscore speed is a private variable, but we are able to update that particular private attribute with the help of function. Okay, but if you talk about the variable Tesla dot brand equals to, if I update this brand to BMW, now you will be seeing print. If I say Tesla dot brand, it will be giving me the updated value. See, BMW, correct? So here we are able to access the attribute and able to assign a value because this is public to everyone. Okay, so that's where this particular inheritance is allowing us to access that variable. Okay, now let's do one thing. Okay, let's do one thing. Let's create our own function here. We say def, or let's copy this one. Okay, and say speed plus 15. Okay, let's say 15. Now let's see the output. What the output will be. Now let me print this thing here also. Let me call before this also here. Okay, and then I can say print and then this line. Okay, let me clear this console. Now you see here we created an object. Our object got created with CMW violet 45 and we got the speed as 45 here. Okay, now as soon as I say Tesla dot set speed, it should say 125. Correct. It should say 125. What what it said? It said 125. Why? Because when we call this Tesla, okay, and Tesla in Tesla we have called the set speed function. Our new speed went here, okay, and as soon as the speed went here, this particular variable is a private, okay. It did not respect this variable, okay, because the function get speed what you are trying to use or consume, it is from this particular class. Okay, so if you are assigning any value of speed outside of that class, it will not work. Okay, now suppose if I copy this function also here, it will also give me the same output because this is very specific to that particular class. Okay, so what it is saying? It is saying Tesla object has no attribute speed, which is correct. Tesla inherited the car, and car has this private variable. This particular variable you cannot use outside of the class. Correct? Now, if I try to set a brand here, okay, let's say new brand. Okay, now new brand, and in my new brand, what I will do, I will append something here. Okay, so I will say underscore 123. Okay, in my brand, so that we will see the updated brand value. Now, in place of set speed, if I say set brand. Okay. In the set brand, if I pass Maruti, okay, or I would say Audi, okay. Now, after getting this, setting this brand, if I say get brand, okay, so I don't have the function for the brand, or I can directly say brand here, okay, and let me print this brand, print brand, okay. And now let me remove all this we don't require. Now let's see what happens. You see, we had this CMW, okay, as a brand we have passed from here. Now we said here Tesla dot set brand. Okay, set brand is nothing but this one. Here we have to say set brand, sorry, my fault. Okay, now let's run. Okay, now here we saw set brand. And first of all, very first thing, because we have created an object of Tesla, it will first check this particular set brand function. Is it available in the current class? No, it is not. Then it will go up. It will look into the parent class. But because we are already having this method in this class, then it will set the brand, okay, Audi underscore 123. After setting it, if you will try to get it, it will get the brand as updated, Audi 123. Now, for example, if I have um, set brand, if suppose I have this one here, define, or let me do one thing. Let me copy paste the similar method, and in place of 123, if I say underscore parent, okay. Now, suppose if I remove this function is not there. Okay, you will see the output. The output is Audi underscore underscore parent because the function is not there. Now it will look for this particular function. Okay, here. And this particular calling sequence of methods, we call it as method resolver something, MRO something. Okay, that particular thing decide where which function will get called. It will take the priority. So first it will take the priority of the current class. If it is not there, then it will check for the parent. Okay, now if suppose I have one more class here, if that particular thing is not in there, this class, it will go to this R2 class here. Okay, and then uh, parent, and similar way it will look in the parent also. So I have a video created for this one. You can go ahead and check that how MRO works. Okay, method resolution for the function. That will give you the complete guidance. Now, this is nothing but the inheritance, which allows us to access the parent class attributes and the methods. And for inheritance, I have created a very detailed video where we talked about multiple inheritance, multi-label inheritance, hybrid inheritance, how it works. Everything is there. Okay, so you can go ahead and check that particular video. Now, let's move forward. Okay, and before we move forward, we discussed encapsulation, we discussed inheritance, correct? Now, apart from this one, we left with the abstraction. Okay, so abstraction, we have to create a new class for the abstraction. But apart from abstraction, we had one more thing, which was polymorphism. Okay, so the polymorphism is nothing, one functions behave differently. Okay, this we call as polymorphism. Okay, now in the Tesla class, we have created a method to override the set speed, correct? So earlier we created a method here, or forget about the test speed method. We have created a method of set brand. Okay, we have given a new definition here. So we said like whenever you are passing a new brand, I will append this underscore 123. So the definition what we had here, we updated the definition. Okay, but the number of parameters, the function name, and the return time is same. Okay, this is nothing but we call it as polymorphism. Okay, where we have same name method, same parameters, and same return time. Okay, now quickly I wish to talk about polymorphism. Polymorphism is nothing but of two types, which is the very first is the runtime polymorphism, and the second one is compile time polymorphism. So the set brand is an example of runtime polymorphism because at runtime, Tesla class look for this particular set brand function. Okay, and if it is not there, it follows the MRO or RMO rule. It will look for in the parent class. Okay. Now the another one is we have compile time polymorphism. So compile time polymorphism, which is a function overloading. traditionally not supported in Python. We have this in Java or C Sharp, but we can achieve same using default parameters. Okay, let's go ahead and see quickly what is static polymorphism. Okay, how we can achieve it. So for example, I have a class calculator. Okay, okay. In this particular class, I am having a function add. Okay, and in this add function, like first is self current object, and then we have a, which is a required parameter, and then we have a b default zero value, c is also default zero value. Okay, now here in the return we are saying a plus b plus c. Okay, now if I wish to call this particular method, okay, what I'm gonna do here is I'm gonna write calc equal to calculator. I can say one. Okay, sorry, yeah, one I can say. Okay, now if I print, or let me not write calc equal to calculator. Okay, then let's create an object. Okay, as we don't have a constructor, so we are not going to pass anything here. Now calc dot add. So function is expecting three parameters, out of which one we need, two are default. Okay, so I'm saying one here, and here I would say print value here. Then if I copy paste, then here I'm saying two, and then I'm saying here 2, 3. Okay. Now if I try to execute this particular piece of code, I'm saying 136, which means here the same method add works for 1, 2, and 3 arguments. This simulates function overloading in Python. Okay. Now here we discussed three core concepts. Now, the last concept which got left is the abstraction. Okay, how this abstraction works. So for abstraction, what we can do, or let's try to understand what is abstraction. Okay, so abstraction is in programming meaning hiding the necessary details and showing only the important features to the user. Okay, we are abstracting something here. Think of it as a TV remote. You know, in TV, how to change channels or increase or decrease volumes, but you don't know, or you don't see how the electronics inside work. Okay. In programming, abstraction allows you to focus on what an object does, not how it does it. So for example, we have multiple modules, correct? In Python, we have NumPy, or we have a Streamlit. Okay. We have a request. Okay. Different Python libraries or frameworks are there. What we do, we just import that. Okay. And after importing that, if we have to call any function, which does a lot of things, okay, there, or take an example of request. In request, if we say request.post, just provide the URL and the data, it will post that particular data to that third-party API service. What we did, we call only one line of code, but at the back end, it might be having multiple line of code, which means we don't know what is happening at the back end. What we know is if we call this particular function, it will do this. This is nothing but the perfect example of abstraction. Okay. Now we have abstract methods also and abstract class also to achieve abstraction. So let's create a class and try to understand the abstraction. Okay. So I would say um, let's create a car class. Okay. Or not car, I would say vehicle. Okay. Vehicle.py. Okay. Now here I'm going to give an import from ABC, from ABC import ABC, comma. Okay, if you see, this is saying helper class that provides a standard way to create an ABC using inheritance. Okay, now here you can say one more thing, abstract method. Okay. Now we have an annotation which says, before that we have to define a class also. So class vehicle, I'm defining a class vehicle. Okay. In this particular class, I'm passing this class as a parent. So ABC is a parent class of vehicle, and this particular parent class in the vehicle class, let's create a function also. Start, okay, and then say self, and then you can say pass. I do not want to do anything here. Now, if you say here abstract method, okay, now I have inherited ABC class. Now inside this particular class, I have this annotations also, okay, which I have mentioned here from ABC. Now what it will do is whenever you are going to inherit, so for example, I have a car class and I'm saying I will inherit vehicle. Okay. Now if I say pass here, okay, and if I try to run this class, see the output. Let's see the output. See, it gave me normally the output, but suppose if I'm going to say here a function or not a function, let's do one thing. Say car equals to, till now we did not get any error because we did not create an object of car class. Okay. So let's create an object of car. Okay. I created that. Now let's execute. What it is saying can't instantiate abstract class car without an implementation of abstract method. Okay. It is saying until you write the definition of this class, you cannot create an instance or object. Okay. Now, if I copy this particular code below, if I give the definition, okay, for example, print vehicle class. Okay. Now, if I try to run this code again, you will see we did not get any error. Why? Because we have implemented this particular method. So abstract class and abstract method, it makes sure whenever you are inheriting any class, if they have abstract method, you have to write the definition or the implementation of that method. Until and unless you don't write the definition of those methods, you will not be able to create the object of class. So this is somewhere we are enforcing to the user to create the or implement this particular method, abstract method. Okay, because it is must to use that particular API or the Python library or whatever it is. Okay. So this is nothing but we call it abstraction. Okay. Now to sum it up, a class, whatever we discussed, I just sum it up. Okay, in like 2 minutes. A class is the blueprint, like a car design. Okay. An object is a real instance created from that blueprint. Okay. And we can create multiple objects using that particular blueprint if once blueprint is ready. Now, properties, which is nothing but attributes, describe what an object has: brand, color, speed. And on the other place, we have method, which is nothing but the action performed by an object. For example, in terms of car, we have start, stop, or accelerate. If we talk about any animal, bark, eating, all those are nothing but an action or methods. Using these concepts, you can model almost anything in programming. Okay, anything what you see or have, you can convert that in a class or object. Okay, just like how object exists in the real world. Anything, any object you can change. And that's all we have for today. Thank you so much for watching this video. If you found this video helpful and want to see more video on Python or AI, don't forget to like and click on notification bell icon to stay updated and subscribe the channel. See you in the next video.